Today's notes, as well as the notes that we cover next class, are all review from what we've done thus far in Unit 4. It is all in preparation for the Unit 4 quiz, which we will take not next class, but the following one. So number 1 asks us to solve the inequality and graph the solution on the number line. We solved one-step inequalities in the previous unit. We also learned how to graph inequalities in the previous unit. But we started two-step inequalities and multi-step inequalities here in Unit 4. So remember, we solve inequalities exactly the same way that we solve equations. We just have one more rule we need to keep track of. Sometimes we flip that inequality around the other way. We do that if we multiply or divide both sides of the inequality by a negative number. So the first thing we need to do here is move this 5 over. Notice it's a positive 5, so I can move it over by subtracting 5 from both sides. My negative 2x comes down. I subtracted on both sides. I didn't multiply or divide, so I do not flip my inequality. I combine these terms. Negative 11 minus 5 is negative 16. This means negative 2 times x. We cancel multiplication with division. Negative divided by negative is positive. 16 divided by 2. We did divide both sides by a negative number. We divided by negative 2, so we need to flip our inequality around. X is greater than 8. And then we sketch in our number line. Make sure 8's on there and at least a couple points on each side of 8. 8 is not part of the solution. It says x is greater than but not equal to 8. So we have an open circle on the 8. And we are trying to shade in the x. Notice x is bigger than the 8. So my shading needs to be bigger than the 8, which would be this side over here. Number 2, same instructions, solve the inequality and then graph our solution. We have x divided by 3 plus 11 is greater than or equal to negative 1. We want to start by subtracting 11 from both sides. I get x divided by 3 is greater than or equal to negative 1 minus 11, which is negative 12. We subtracted on both sides. We do not flip the inequality. To cancel division, we multiply both sides by 3. Negative times positive is negative 36. I multiplied both sides by positive 3. Therefore, I do not flip my inequality around. Even though this was a negative number, what I multiplied both sides by was a positive. Again, it asks us to graph. It's not a very horizontal line, but we'll go with it. Negative 36 needs to be on there. Because it's negative, as I get bigger than negative 6, this is going to be negative 35, negative 34. Smaller would be negative 37, negative 38. X is greater than or equal to negative 36 because it could be equal to. We have a closed circle on the negative 36. And again, x is bigger than the negative 36. I'm trying to shade in the x. I want the numbers bigger than negative 36, which again is to the right. Number 3, same instructions, solve our inequality, graph your solution on the number line. This one looks like we've got x's on both sides. We also need to start by distributing. I've got 5 times 2x. and 5 times negative 3. Three times 2 is 6, and 3 times 3x is 9x. If I have x's on both sides of my equal sign, I need to move them all over to the same side. So in this case, I need to either move the 10x over or the 9x over. It's usually easier to move the smaller one. Let's move the 9x. Subtract 9x from both sides. My 6 comes down. This sign stays the same. I subtracted. 10x minus 9x, that's 1x. 1x, usually we just write as x. Minus 15. And now I can add 15 to both sides. And we have solved the inequality. We get x is greater than 21. 21 goes on my number line. X could be greater than 21, but not equal to. So I need to shade in to the right again with an open circle. Number 4, solve and graph our solution on the number line. We've got a number out in front of parentheses. We start by distributing. 4 times 2x is 8x. And then I've got 4 times negative 3. This part just gets copied down. Now we combine like terms. This 8x and the minus 10x. On the last one, the x's were on different sides of the inequality. This time they're on the same side. If they're on the same side, we just combine them. 8x minus 10x, that gives me negative 2x. And then I've got my minus 12 is greater than negative 2. To solve for x, we want to add 12 to both sides. Negative 2x comes down. Negative 2 plus 12. When I add, we do not flip our inequality. Divide both sides by negative 2. When we divide by a negative, we do need to flip that inequality around. X is less than negative 5. We are asked to graph our solution on the number line as well. So negative 5, as we get bigger than negative 5, negative 4, negative 3, we're getting closer to 0. Negative 6, negative 7. We have an open circle. X cannot be equal to negative 5, so it should not be shaded in. And this time, the negative 5 is the bigger one. So I'm trying to shade in the x. Negative 5 is bigger than my shading, so I shade in to the left. Number 5, we have had enough practice with graphing. Let's just go ahead and solve this one. It simply asks us to solve. Start by distributing. 2x times 2x is 4x. 2 times 8 is 16. And I bring my 4x minus 9 down. I've got x's on both sides. I need to move them over to the same side. I can do that by subtracting 4x from both sides. And notice all of my x's cancel out. 4x minus 4x is 0x. I don't have any x's left over here. I just have 16. And on this side, my 4x minus 4x canceled out, and I just have negative 9. When that's the case, this is one of the special cases that we have. We want to check to see, is this statement always true or never true? 16 is indeed bigger than a negative number. So this is a true statement. When that's the case, we say all real numbers are solutions, or infinitely many solutions. All real numbers are solutions. Let's take a look at another one. Let's call this one number 6. I didn't have this one on there, but again, let's say solve. Let's go 3 times the quantity 2x minus 1 minus the quantity 6x minus 7 is less than 2. Three times the quantity 2x minus 1 minus the quantity 6x minus 7 is less than 2. We are just asked to solve the inequality. We do not need to graph. Start by distributing. 3 times 2x is 6x. 3 times negative 1 minus 3. Here I'm distributing a negative 1. If there's no number there written there, it's the same thing to be a 1. So I've got negative 1 times 6x and negative 1 times negative 7. Negative times negative is positive. Combine like terms, 6x minus 6x. Those cancel. I get 0 x's. Negative 3 plus 7 is 4. Again, all of my x's canceled out, and I get down to 4 is less than 2. Four is not less than 2. This is a false statement this time. 4 is never less than 2. No matter what x is, I cannot make 4 less than 2. I have no solution. Number 7. Number 7 asks us to graph the compound inequality. Graph the given compound inequality. So let's make sure that we have 4 and 7 on there, maybe a little bit more in each direction. For an or statement, that means this one could be true, or it's possible this one could be true. Either of them could be true. Therefore, I want to shade in the x values that are less than 4. Those are the x values less than 4. Those all make the statement true. Or x could be greater than or equal to 7. So for an or statement, I shade in each inequality. And our final review problem for today, number 7, asks us to graph this compound inequality. Not number 7, it's number 8. It says negative 3 is less than x is less than or equal to 5. Negative 3 is less than or x, which is less than or equal to 5. These are a little more spaced out, so I'm going to count by 2's here. So I got negative 4, negative 2, 0, 2, 4, 6. Because x has to be bigger than the negative 3, we do not have the or equal to, so we put an open circle at negative 3. X could be equal to 5, so close circle at 5. And notice my x has to be bigger than the negative 3 and also smaller than the 5. The x is in between the negative 3 and the 5. The shading goes in between negative 3 and 5. that is it for today's notes. We will continue reviewing for that Unit 2 quiz next class.